Welcome back, children, to the second video on elasticity chapter. In the first video, we discussed important relations, interrelations in this chapter and solved few problems. We'll continue with the fifth problem, a problem similar to this you can solve. Let's read now. Two wires A and B made of same material. Same material. As soon as you read this word, what do you understand? Young's modulus, because the wire of wire A is equal to Young's modulus wire B. Like this only, you have to collect information while reading. Continue. Their lengths are in the ratio 1:2. So let's analyze here itself. LA that equal to LB 1:2. And their diameters are in the ratio 2:1. Diameter of A is to diameter of B is 2:1. If they are pulled by the same force, their increase in length will be in the ratio. You have to find the increase in length delta L of A to delta L of B wire B. First of all, in our previous discussions, problems, we wrote expression for force in terms of Young's modulus, delta L divided by L into area. How do you get it? It's very easy. What is Young's modulus? Young's modulus of a wire, it is a force per unit area into delta L by L, that is L by delta L, because it's actually denominator delta L by L. Force per unit area, stress by longitudinal strain. So you solve for F because force he wants. Force is same, is pulled by same force. Then what is area? Y delta L by L. Area of cross section here, as it is a cylindrical wire, what do you write for area? Pi r squared. Nodi, ನಿಮಗೆ ರೇಡಿಯಸ್ ಅಂಡ್ ಏರಿಯಾ ರಿಲೇಷನ್ diameter familiar. So radius is half of diameter and diameter 2 times radius. So if you square it and write delta L by L into pi d square by 4. Since he says in the problem, force applied to wire A is equal to force applied to wire B. What are you thinking actually here? See, students, actually there are two wires. One end is fixed. From the other end, a weight is applied, load, itara, pulled by a force FA. Another wire suspended from a rigid support, and that also being applied, that also being pulled by the same force. FA is equal to FB. That's what you have to think. So what do you write here? For FA, you can write this formula. F is Y delta L by L pi d square by 4. So I write Young's modulus of wire A, YA, into delta of A divided by L of A into pi d square by 4. D square means for wire A. Write the same values for wire B, YB, into delta LB divided by LB into dB square by 4 into pi square. You can cancel out pi square. You need not write this. I am showing this calculation. Don't try this again and again. Try all this in mind. And YA equal to YB, because that's what he says in the given problem. Therefore, you solve for, you are left with on the left side delta L for A, L of A, D diameter of A squared, and that equals to delta L A B LB into diameter of B whole squared. Now you continue from here. If you continue down here, you solve for extension of the wire A to that of B. It's very simple. Now you can simplify it. Nodi, delta A kade you ಉಳಿಸ್ಕೊಂಡು ಡೆಲ್ಟಾ ಬಿನ ಕೆಳಗಡೆ ತೊಗೊಬರ್ತೀರಾ. ಲೆಂತ್ ಗೋಸ್ ಟು ನ್ಯೂಮರೇಟರ್ ಆನ್ ದಿ ಅದರ್ ಸೈಡ್ ಡಿವೈಡ್ ಬೈ ಎಲ್ ಬಿ. ಇಟ್ಸ್ ವೆರಿ ಈಸಿ. ಇಂಟು ಡಯಾಮೀಟರ್ ಆಫ್ ಬಿ ಇಸ್ ಆಲ್ರೆಡಿ ದೇರ್, ಆಫ್ ಎ ಗೋಸ್ ಟು ಡಿನಾಮಿನೇಟರ್. ಇದು ಸ್ಕ್ವೇರ್ಡು, ಹಾಗಾಗಿ ಯು ರೈಟ್ ದಿಸ್. Therefore, you write this way, delta L of A to delta L of B, that equal to, what's L of A? Ratio of length of A to that of B, 1/2. That's why he gives into dB by dA. dA by dB is 2:1. dB by dA 1/2 whole square. So it is 1/2 into 1/4. That's equal to 1/8. So you may solve quicker than me. That's why you give pause. You watch once, try on your own, then you proceed. If you can't do on your own, you skip this and continue. You watch once full and try on your own. ಈ ಥರ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋದೇ ಇಸ್ ಪ್ರಿಪ್ರೇಷನ್ ಫಾರ್ ಸಿ ಇ ಟಿ. ಇಷ್ಟು ಟೈಮ್ ಕೊಟ್ಟು ನೀವು ಯೋಚನೆ ಮಾಡಲೇಬೇಕು. ದಿಸ್ ಹೌ ಸಿ ಇ ಟಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಫಿಸಿಕ್ಸ್. ಫಿಸಿಕ್ಸ್ ಅಂದರೆ ಹೀಗೇನೆ. ನಾರ್ಮಲಿ ಯು ಫೀಲ್ ಇಟ್ ಬಿಟ್ ಟಫರ್, ಬಟ್ ಇದೆಲ್ಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಈಸಿ ಆ್ಯಕ್ಚುಲಿ. ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ರಿಲೇಷನ್ ಮೈಂಡ್ಲಿರಬೇಕು. ಆ್ಯಂಡ್ ಯು ಪ್ರೊಸೀಡ್ ಅಕಾರ್ಡಿಂಗ್ಲಿ ಏನೇನು ಇಲ್ಲಿ 2 ವೈಯರ್ಸ್, ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಆಫ್ ಎ ದಟ್ ಈಕ್ವಲ್ ಟು ಬಿ, ಆ್ಯಂಡ್ ಲೆನ್ಸ್ ಆರ್ ಇನ್ ದಿ ರೇಷಿಯೋ 1:2, ಡಯಾಮೀಟರ್ 2:1, and you write expression for force y delta L by L into A. That's it. Young's modulus relation. You are playing with the relation. Answer is 1:8. Your option C. ನೋಡಿ, ಇದಿಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಹ್ಯಾಸ್ ಶೋನ್ ಹಿಯರ್. ನೋಡಿ, ಇಷ್ಟು ನೀವು ಮೈಂಡ್ನಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತೀರಾ. ಒನ್ಸ್ ಯು ಪ್ರಾಕ್ಟೀಸ್ ದಿಸ್ ಮಚ್, ಕೀಪ್ ಇನ್ ಮೈಂಡ್, ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಆ್ಯಂಡ್ ಅಪ್ಲೈ ಡೈರೆಕ್ಟ್ಲಿ. ಇಫ್ ಯು ಆಸ್ಕ್ ಮೀ ಡೈರೆಕ್ಟ್ಲಿ ಇನ್ ಎಕ್ಸಾಮ್, ಐ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ಹಿಯರ್ ಬಿಕಾಸ್ ಐ ನೋಟಿಸ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಇನ್ ದಿ ರಿಲೇಷನ್ y delta L by L into A. Force same, Young's modulus same, then you equate this. Delta L by L into A of wire A is equal to delta L by L into A for wire B. That's it. Straight away I'll reach this formula. From this I'll reach this. You practice this. Practice madre baratte. We'll move on to next problem. Okay. Next one. 2 rods of different materials having coefficient of linear expansion alpha 1, alpha 2, Young's moduli y1, y2 respectively are fixed between 2 rigid massive walls. Their rods are heated such that they undergo same increase in temperature. There is no bending of rods. Alpha 1 is to alpha 2, 2:3, and thermal stress developed in the two are equal, then y1 is to y2 ratio. Now, thermal stress, I proved this relation, thermal stress formula. Thermal stress means force. Force, that is F, that equal to, you wrote Y alpha, that is delta theta into A. This is thermal tension. If I bring this here to the denominator, force per unit area, that is thermal stress. Okay. Thermal stress for both the materials, A and B same, right? How do you get it? I explained you, but I'll show you once again. Nodi, when you consider conduct, this is what he says. There are 2 rigid blocks, right? Rigid block. The two blocks, a wire is fixed. Actually, when you heat by supplying or applying heat, the length increases normally. That is called linear expansion. The coefficient of linear expansion alpha, you have learned thermal properties of matter. ಏನು ಕಲ್ತ್ಕೊಂಡಿದ್ದೀರಾ? ಎಷ್ಟು ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಯಿತು. ವಾಟ್ ಇಸ್ ದಿ ಇನಿಷಿಯಲ್ ಲೆಂತ್ ಪರ್ ಯೂನಿಟ್ ಚೇಂಜ್ ಇನ್ ಟೆಂಪರೇಚರ್. ಫಾರ್ change in length, you practice this, get it by heart. You have learned this in thermal properties of matter. ಇದೇ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಮುಂದೆ ಏನು ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. You have to remember this. So delta L, alpha L, delta theta. But because of the increase in length, no space increase ಆಗಲಿಕ್ಕೆ, so the increase in length exerts force over the two ends. That force is given by F that equal to y, ಈಗ ತಾನೇ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ, ಡೆಲ್ಟಾ ಎಲ್ ಬೈ ಎಲ್ ಇಂಟು ಎ. ನಿಮ್ಮ ಮೈಂಡ್ ಹೇಗೆ ಓಡಬೇಕು? ಬಿಕಾಸ್ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ ಡಿವೈಡೆಡ್ ಬೈ ಡೆಲ್ಟಾ ಎಲ್ ಬೈ ಎಲ್. ನೋಡಿ, ಇಲ್ಲಿಂದ ತೊಗೊಳ್ತೀರಾ, ಸಾಲ್ವ್ ಮಾಡಿದಾರೆ ಫೋರ್ಸ್ಗೆ ಅಷ್ಟೇ. ಇದೆಲ್ಲ ಮೈಂಡ್ನಲ್ಲಿ ರಿಲೇಷನ್ಸ್ ಇರಬೇಕು. ಯು ಹ್ಯಾವ್, ಓಕೆ, you use the value of delta L. What is delta L? Y times alpha L delta theta divided by L. It cancels, area remaining. So you are left with for force Y alpha delta theta change in temperature into area. Now you divide area, it becomes thermal stress. Thermal stress for both the materials, F by A for material 1 is equal to F by A for material 2. That's it. So You can write y1 alpha 1 delta theta that equal to y2 alpha 2 delta theta. You are not writing delta theta 1 delta theta 2. Why? Because their rods are heated such that they undergo same increase in temperature. So change in temperature same for both. Therefore, I'll continue here. What's left side? y1 alpha 1 that equal to y2 alpha 2. So you solve for the ratio y1 to y2 that equal to alpha 2 to alpha 1. What is alpha 2 to alpha 1? Alpha 1 to alpha 2 is 2 is to 3. So alpha 2 to alpha reciprocal of that 3 is to 2. So the ratio is 3 is to 2. Option A. This way you can try this. And once again, it is a repeat problem that we solved already. That is thermal tension. Thermal tension antidhagane. Get it by heart. Y alpha delta theta A formulas by little. You will continue. So you need to remember all the relations. ನೆನ್ಪಿಟ್ಕೊಳ್ತೀರಾ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ ಮುಂದೆ ಹೋಗ್ತೀರಾ ನೆನ್ಪಿಟ್ಕೊಳ್ತೀರಾ ಅಪ್ಲೈ ಮುಂದೆ ಹೋಗ್ತೀರಾ. For this you require to solve more and more problems. Okay, keep solving problems. We'll move on with one more students. Yes, next one. The stress required to double the length of the wire of Young's modulus Y is. Already have shown this part of the proof. I have shown written quickly. But what do you think actually? See students, you have to think like this. Quickly you have to think. There is a wire of length say L. ಇಲ್ಲಿವರೆಗೆ ಇದೆ length. This is what you have to think. What is the stress required? Where do you apply stress? You apply stress like this. Force per unit area stress. You are applying force per unit area over here. Apply ಮಾಡಿದಾಗ the length of the wire increases by L. Increase by L means total length becomes 2L. ನೋಡಿ ಇಲ್ಲಿವರೆಗೆ L ಇತ್ತು, further L, ಇದು L. So change in length also L. Initial length L. Both are same. Now the formula, what is Young's modulus? We all know Young's modulus Y, force per unit area, that is stress, divided by delta L by L. He wants you to find first stress. What is stress? Stress is Y times delta L by L. So what is Y? You want Y. What is L? Change in length L. Initial length also L. L cancels. So stress that equal to Y. Stress is Y. Very simple. Increase in length L. Original length L. L by L 1. So Y. That's it. It's very simple. Yes. There is another repeat problem on thermal tension. Thermal stress. Can you recall that relation, students? Come on quick. What is thermal tension? Thermal tension, that is force, thermal force developed when the two ends are fixed rigidly and heated, is given by Y times alpha delta theta times A. Delta theta change in temperature. How do you get it? Quickly. Fatafat. How do you obtain this relation? From thermal expansion formula, coefficient of thermal expansion, change in length by original length into change in temperature. From this you solve for delta L, that is change in length. Again I am telling you, ಇವೆಲ್ಲ ಫಾರ್ಮುಲಾ ಬೈಹಟ್ ಮಾಡಿಬಿಡ್ಬೇಕು ನೀವು. So increase in length is alpha times original length into delta theta. But what is Young's modulus? Why? Force per unit area, right? You want force, right? You are force. Okay, is once again delta L divided by L. So you solve for F. F is Y into delta L by L into A. Y into what is delta L? Delta L here. You put that value here. Alpha L delta theta divided by L into A. L cancels. So Y into alpha delta theta into A. When this part is not required, illinda illivari explanation not required, skip this. Run the video faster. Then you come back to this formula. Straight away this formula. So I remove this now. You are all familiar with this. You have to be familiar with this. Thermal tension ಅಂತಿದ್ದಾಗೇನೆ come to this formula. Thermal stress ಅಂದರೆ F by L ಮಾಡ್ಕೊಳ್ಳಿ. F by L. What he wants you to find? Magnitude of force developed. So you have to solve for F only. What is the value of Y? Y is, he says, I'll continue here. I have enough space. That's Y 10 to the power 11 into 10 to the power minus 5 alpha into change in temperature. 0 to 100 is change. There is theta 1 and this is theta 2. What is theta 2 minus theta 1? 100. That's it. 100 means 10 power plus 2. 100 becomes 10 power plus 2. You think like that. See it in the hange vishya madabeko. What is area? 1 centimeter square. 1 10 to the power minus 2 whole square. Now you simplify. 10 power 11 minus 5. Right, 10 power for 11 into 10 power 11 actually this. 10 power 11 into 10 to the power minus 5 into 10 to the power plus 200. 10 to the power minus 4. So finally the answer is 10 to the power 4 Newton. Check this once again, the calculation part. The procedure is this much, very simple. The students move on. Steel wire of 1 meter long. Initial length L is given. L 1 meter and 1 mm square area A is given. If it requires 200 Newton force, initial force 200 to stretch the wire by 1 mm. See, he has given delta L, area and force required. The force required, next you continue from second line. The force required to stretch the wire of the same material. Same material means what? Young's modulus same. Keep that in mind. Same diameter from its normal length 10 meter to 10.02 meter. Here same diameter means you need not use area. Area same. Same material. That's why you have expression for force in terms of Young's modulus. Young's modulus F by A delta L by L. Solve madadre F is delta L by L times area. Since area same, Young's modulus same. How do you know? Same diameter 1 mm square ಅದೇ ಹಾಕೊಂಡ್ರೆ ಅದು ಕ್ಯಾನ್ಸಲ್ ಹೋಗ್ಬಿಡುತ್ತೆ. Same material implies y same. So you have a relation for force delta L by L times. That's all. Delta L by L. That's it. So for two materials you write this. Once you identify a relation like this, force for material 1, material 2 in fact, I want for second material, divided by force for material 2, that equal to, very simple, delta L, F2 ಗೆ delta L ನ್ಯೂಮರೇಟರ್ ಹೋಗುತ್ತೆ, F1 ಗೆ delta L ಡಿನಾಮಿನೇಟರ್ ಬರುತ್ತೆ, ಇಂಟು ಇನ್ವರ್ಸ್ ರಿಲೇಷನ್ ಆಗಿರೋ ಲೆಂತ್ಗೆ F2 ಇದ್ದರೆ ಡಿನಾಮಿನೇಟರ್ನಲ್ಲಿ L2, F1 ಡಿನಾಮಿನೇಟರ್ ಇರೋದ್ರಿಂದ ಅದರ ಲೆಂತ್ ನ್ಯೂಮರೇಟರ್. ದಟ್ಸ್ ಇಟ್. ವೆರಿ ಸಿಂಪಲ್, ವೆರಿ ಈಸಿ. ನಾವು ಯು ಕಂಟಿನ್ಯೂ ಲೈಕ್ ದಿಸ್. You put the values, we'll continue, illa continue ಮಾಡ್ಕೋಣ. This space is enough for me from here. Okay, what is delta L2? Delta L2, he wants, here is 1 mm, here it is centimeter, meter 0.02, 1 mm 0.02 mm. Yes, if you put the value, what is delta L? Second case nalli 10 meter in the 10.02 meter. So what is delta L to second case? 10.02 minus 10, that is 0.02. 0.02 divided by 1 mm into 1 by 10. So you want F2 by F1, that equal to, you convert this mm into meter. 10 power minus 3. Minus 3 comes to numerator. Numerator 1000. 1000 multiply ಮಾಡಿದ್ರೆ 20 divided by 10. This is 10. So 1 0 cancels 2. ಆವಾಗ F2 ಬೇಕು ನಿಮಗೆ. That is F1 ಈ ಕಡೆ ಕಳಿಸ್ಕೊಳ್ತೀರಾ. 2 times F1. So that is 2 times 200. That is F1 here. F1. Force in first case. 400 Newton. 400 is not there. You can make one of these two here. One of these two, 400 Newton is not there, but the procedure is correct. You have to write F proportional to delta L by L. Then rest is very simple. You need to practice. So another one, for a steel, the Young's modulus of and strain at breaking point are 2 10 power 11 Newton per meter square. What is this? Young's modulus and 0.15 respectively. So what is this 2 10 power 11 Newton per meter square? That is Young's modulus and the strain at breaking point when the string breaks. What is strain? Delta L by L. He has given that value. That is strain actually, strain. Then the stress in Newton per meter square at break, very simple Young's modulus, already shown. How do you get this relation? Y that equal to stress divided by strain. From this you have solved for stress and you put the value of stress y 2 10 power 11 and strain 0.15. The final answer is 3 10 to the power 10. You check this calculation part once. It's very simple. Children, we'll have one more. A wire of length L and radius R is rigidly fixed at one end. One on stretching the other end of the wire by force F. The increase in length is L. Delta L is L. You take this delta L. This term is here. This term is delta L. While reading the formula, you have to collect data like this. Delta L is L and L is L only. Radius R, force F. Next he says, continue from here. If another wire of same material, Young's modulus same, but length 12, radius 2r, force 2f, the increase in length will be. Young's modulus formula here, this Young's modulus. Can you identify this part? No, I'll show the calculation part once again. You continue from here. I'll write what is the delta L. Delta L. How do you write delta L? Delta L that equal to, you bring this to numerator, this A to denominator, Y to denominator. So it becomes F divided by A into L divided by Y. L by delta L that equal to Y. Y na transfer ಮಾಡಿ ಹೀಗೆ ಈ ಕಡೆ ಹಾಕೊಂಡ್ರೆ ಇದು ಹಿಂಗೆ ಹೋಗಿದೆ, ಇದು ಹೀಗೆ ಬಂದಿದೆ ಅಷ್ಟೇ. This is one case. For one case. Now you write this. E formula use ಮಾಡಿ first case 1 ಗೆ you write this delta L1 that equal to F1 by A1. A1 we write. What is A1? A1 is, I'll write this way. I remove this. Okay. First you solve for A. Let's see A. Then you'll go to case 1. What it says about A? A is F, as it is a cylindrical wire. He has given the radius, so write area pi r square. So L divided by Y. This formula you have to apply for the first case. In the first case, increase in length, delta L1, let's write F1 L1 divided by pi R1 square Y. Y. You are not writing Y1 because same material. Case 2, what do you write? Increase in length second case, F2 second case, length second case, pi R2 second case and Y, that's it. You have to find ratio. Increase in length is the second case, that's why delta L2 divided by delta L1 that equal to, if you divide, delta L2 F2 divided by F1, you call this 1 and you call this 2, you are dividing 2 by 1, that's it. If you do 2 by 1, 2 by 1, F2 by F1, L2 by L1, L2 by L1 into denominator on the radius. So L2 ge R2 denominator and R1 L1 denominator on the radius R1 numerator, whole square. Whole square is very important. What he says now, and pi cancels, Y cancel because same material. What's F? Second case nalli 2F ತಗೊಳ್ಳಿ. First case F into what is length in the second case 2L and in the first case L into radius wise first R second 2R whole square. So delta L2 divided by delta L1 that equal to F cancels, L cancels, R cancels, numerator 2 2s are 4 into 1 by 2 squared 4, 2 squared 1 by 2 squared, that is 4. 4 cancels 1. So delta L2 by delta L1 is 1, which implies delta L equal to delta L1. Delta L1 L ತಗೊಳ್ಳಿ ಅಂತ ನೋಡಿ, by L we are stretching it. So delta L1 increase in length L ಆದರೆ delta L2 L ಆಗುತ್ತೆ. That's all. That is the option A to this. Moving on, we'll see one more, almost similar. The following 4 wires made of same material again. What do you think? Young's modulus of wire A R1 1 is equal to that of 2, that is equal to that of 3, that is equal to that of 4. There are 4 wires. Which of these will have the largest extension when same tension is applied? And really, 4 materials means 4 options. See, one material wire having length 50 centimeter, diameter 0.5 centimeter, mm. Same material but length 100 centimeter and diameter 1 mm. Another same material wire 200 centimeter, diameter 2 mm. 300 centimeter, diameter 3 mm. Now we need to find what is the extension in terms of length and diameter. Now the hint for this problem is very simple. We have already given the Young's modulus y f by a delta L by L. It's very simple. Yes. Here same tension, when same tension is applied for the same tension means force same, diameter different. You convert this into diameter f divided by a times L by delta L by delta L, this way. Now we can solve one step further. Let it be like one step further. How? Solve for delta L. What is delta L? Delta L is f divided by a times L by, you bring y to the denominator, or f divided by a. What is a? Pi r square, where r is d by 2, d square by 4 into L by y. In our discussion, force, Young's modulus, pi, 4 are constants. Therefore, we will continue with increase in length delta L proportional to initial length divided by square of diameter. This formula we are going to use. That's what he says here in this problem. Increase in length formula is this. Now you go option 1. Now the first option, you will find delta L for first option proportional to L by d square. Now you do it in the same unit because all options 5 centimeter, millimeter, centimeter, millimeter, that's why. L 50 centimeter, you write 50. Okay, L 50 centimeter divided by diameter squared 0.5 squared mm square. So the ratio 50 centimeter divided by 0.5 is 0.25 centimeter. So you multiply divide by 100, 5000 divided by 25. 25 twos are, it comes around 200 centimeter divided by mm square. This is the ratio. That is delta L, right? L by d square. So now check the same L by d square for all other options. Second one, we'll do it quickly. Delta L for the second one, proportional to L 100 centimeter divided by diameter 1 mm squared. So the value is 100 centimeter per mm square. Now look at the option C. For option C also, delta L 200 centimeter length divided by diameter 2 to the 4 mm square. So it is 50. And the last one, delta L proportional to L by 100 minus L by L d square. L is 300 centimeter divided by d square 3 mm squared. So you get 300 centimeter divided by 9 mm square. So it comes around 9 threes are 27, 9 threes are 27, 33 point or something. So which is maximum? Option A is coming around 200. So the ratio L by diameter square, which is increase in length, is maximum for option A. Like this you have to identify. You go by the options for which in the given options ratio L by d square maximum, that is delta L. So this is how the Young's modulus has been used in setting different types of problems. See, we have been using the same formula for Young's modulus. How it has been used in various problems, f divided by delta L by L. What is this? Stress. That too, normal stress divided by longitudinal strain. ಇದನ್ನ ಯಾವ ತರ ಸೆಟ್ ಮಾಡಿದ್ದಾರೆ ನೋಡಿ. You practice all these types. Keep in mind This is how you have to use like that. You program your mind. You will continue further. Moving on. With the rise in temperature, the Young's modulus of a wire of elasticity. Young's modulus, Y, that equal to F divided by A, stress divided by longitudinal strain. And you can write a formula that is F divided by A, L by delta L. Continue further. But he says temperature, with increase in temperature, what happens to Young's modulus? How do you bring temperature into this formula? You bring it by using, already we have learned relation between Young's modulus, coefficient of linear expansion. On heating, wires expand. So coefficient of linear expansion, ratio of increase in length to its original length per unit increase in temperature delta theta. Here it is, increase in. So you solve for delta L, alpha L delta theta. Therefore, the value of Y, that is F divided by A into L divided by what is delta L, alpha L delta theta. So you can cancel out L. Finally, he wants you to find the relation for Y in terms of delta theta. So, Y inversely proportional to delta theta. What is the meaning of this? Increase in temperature decreases the value of Y. Inverse related. You can easily realize it also. If you heat, substances expand. So, you need to apply less stress. As they expand, the force required is lesser. Force required lesser means Young's modulus lesser. Stress is less, Young's modulus less. That's the idea. Stress by strain. So temperature inversely proportional to Young's modulus, which means increase in temperature decreases Young's modulus. Option A. That's it. Now come to 14, problem 14. In the 14th problem, Young's modulus of perfectly rigid body. What is Young's modulus? Young's modulus, basically you learn this way. Why? Stress divided by strain. For a perfectly rigid body, what is strain? Delta L by L. Perfectly rigid body, strain is 0. No change in length. You cannot change the dimension. That's why it is a perfect rigid body. That's why stress divided by 0. Anything by 0 is infinity, not defined. So the option is C. One more. A wire of length 1 meter. Actually, L is 1 meter. L. Collect data while reading. Area of cross section A 1 centimeter square. So how do you, since SI unit is used here in options and also the most of the values, you convert area here itself into meter squared. 1 10 power minus 2 whole squared. So it becomes 10 power minus 4 meters squared. That's it. The Young's modulus of the wire is 10 power 11 Newton per meter square. The force each equal to F are applied on the two ends in the opposite direction. If the change in length be 1 mm, how do you write 1 mm? 1 10 raised to power minus 3 meters. What is the value of F? The situation, there is a uniform cross-sectional wire. At both ends you are applying a force, F. So what is total force applied? Total force applied is 2F per unit area whole divided by delta L by L. What is this? Young's modulus. So you have to solve for F. So right, that's why you just cross multiply and solve for F. 2F. You just do it in mind. It's in denominator. A goes to Y side. Y times A delta L divided by L. This is what you learned, right? Now, you will put the values. Therefore, this implies, I will continue here. Continue this part 2F. I have 2F on the left side. And on the right side for Y, you put 10 power 11. For A 10 power minus 4. Area itself given here. Not area in terms of radius, diameter, athra. What's change in length? 1 mm, 10 power minus 3. Divide what's original length? 1 meter. That's it. So you solve for F. You bring it to this denominator. What's 1 by F? 1 by F is 0.5, 0.5, 10 raised to the power. You do power calculation simplification, 4 Newton. That's it. The option in this problem. Option is A. That's it. This is another type of Young's modulus. A thick rope of density rho, density is given. Density means what do you think? Mass. Whenever you say mass, density into volume. Like that you have to make substitution. Length L is hung from a rigid support. The Young's modulus of the wire is Y of the rope. The increase in length, you have to solve for increase in length. Same formula, see this only we will be using. And you will calculate now Y Young's modulus, F divided by A into L by delta L, right? You want delta L. What is delta L? Increase in length. F divided by A into L by Y. Now what he says, there is a uniform cross-sectional wire suspended, hung from a rigid support. Upper end is fixed at the wall or ceiling, say. The lower end is having a length. What is the length of the wire? Length of that is maximum L, full length. Full length of the wire is L. As it's a uniform cross-sectional wire, where does the weight act? Exactly at the center of mass exactly lies here, weight lies here, weight. Entire wire weight lies at the center. What's weight? Weight is mg. So you put for weight, that is mg. The string is experiencing force here, pulling force down at this point, center of mass. So this portion of the string experiences a increase in length. So this feels as if somebody pulling down with a weight mg. So force applied is mg, and length in which the extension takes place is L by 2. So you use L is L by 2. That's what you have to remember. Now we'll continue. Delta L, that equal to, what is F? F is the weight. What is that weight? mg into L by 2 divided by Y, Young's modulus, into A. A given? No. A is actually, yes, A is there here. A is here. Now I will continue further. What you will get, you'll see now. Delta L, mass is not given. He has given mass in terms of density. What is density? Mass by volume. So mass is density into volume. What's volume of cylindrical wire? Length into area, right? Length into area. Therefore, for M you write rho AL into G into L whole divided by A into 2Y. So A cancels. You are left with half times rho G L 2 times L square divided by Y. So we have to go with the option B. That's it. So what extra you understand? For a uniform cross-sectional wire, the length is L, weight acts exactly at the center of mass, point where entire mass is supposed to be concentrated, that is center of the wire. So the extension takes place in this part. For L, you have to use L by 2. Weight acts at the center, upper portion is L by 2. That length you have to use. And for mass, very important, because numerical problems ಕೇಳಬಹುದು ಇದರ ಮೇಲೆ ಏನು they give volume or area, length, density, right? Find increase in length. That is the question. ಆವಾಗ ನೀವು put the, first of all you remember this as a formula. If you forget, no worry, you start from Y, F by A, L by delta L. F is its own weight, that's why mg. For some other problems, wire holds a weight, if that is the problem. Only one end of the wire is fixed to resistance, other end connected to a weight. What is the force now to the entire weight? That is mg. That's it. M will be given, G will be given. G is already known, that is 10. Now I will continue. ಅಂದರೆ ಫೋರ್ಸ್ ಪ್ಲೇಸ್ನಲ್ಲಿ ಎಮ್ ಜಿ ಯೂಸ್ ಮಾಡ್ಬೋದು ವೆನ್ ಇಟ್ ಸೇಸ್ ವೆಯ್ಟ್. ಇಲ್ಲಿ ವೆಯ್ಟ್ ಯಾರ್ದು? ಸ್ಟ್ರಿಂಗ್ ಇಟ್ ಸೆಲ್ಫ್. ವೇರ್ ಡಸ್ ಇಟ್ ಆ್ಯಕ್ಟ್? at the center of mass. ಹಾಗಾಗಿ what is L? L by 2. L is L by 2. Y Young's modulus. Force is mg. M is density into volume. Volume for a cylindrical wire, length into area. Like this, you program your mind. When a problem appears in this direction, you will use it, right? We'll move on. Okay, it's now on bulk modulus. A solid sphere of radius 20 centimeter is subjected to a uniform pressure 10 power 6 meter square. If the bulk modulus of the material of the solid is 1.7 10 power 11 Newton per meter square, decrease in volume of the solid approximately equal to, what's bulk modulus? B, change in pressure or just pressure, force per unit area, stress also pressure, is delta V by V. What you have to find? You have to find delta V. So you bring it to numerator V. Delta P divided by B, bulk modulus, times V is decrease actually. You should have written minus sign. Let's write minus. No minus sign in the options. Just value you have to identify. Now we'll continue from here. Delta V. What's P? Pressure. Pressure applied is 10 power 6 Newton per meter square. What's volume? Radius. Actually, you convert this formula now familiar. What is volume? 4 by 3 pi r cube, because radius is given. So 10 power 6 divided by 1.7 10 to the power 11, that is bulk modulus B, into 4. Let us remove this. Okay, 4 divided by 3 pi 3.14 into 10 raised to the power 20 cube. How do you write 20 cube? 20 centimeters, 20 10 power minus 2 meters, because units are in unit is in CGS. Okay, you can write in centimeter itself, centimeter cube. We'll do it in meter, then we'll continue. So it becomes 2 10 power minus 1, because 1 0 cancels. Cube this. If you find cube of this, I'll remove 3.14 into r. R is 2 10 power minus 3 whole cube. 2 cube is 8. Whole cube 10 power minus 1 minus 3. So you are left with the value. How much? Numerator 4 into 3.14 into 8 divided by 1.7 times 3 and the power 10 raised to the power. Look at the value. Here 11 comes to numerator, minus 11. Minus 11 minus 3 minus 14. Minus 14 plus 6 minus 8. That's it. Now you can approximately find the value. So 3 ones are slightly more than 1. Okay, no problem. 1.7 nearly 2. Let's round off to higher value. Taking higher value nearly 2 and divide, the answer will be lesser than the actual. That's why we can easily guess. 2 4s are. Actually it is bit more than 4. 4.2, 4 like 4 4s are 16. 4 4s are 16. You're getting a value around 16. Is nearly, is more than 16, around 20 maybe. 10 raised to the power minus 8. Now minus 8. Now if I shift by one place, if I write 1.6, it becomes 10 to the power minus 9. So 1.6 nearly 2, actually 2.2. Okay, right? 1.2. Here you can do the or approximate the answer quickly, because in the options, look here, option 0.2, 0.3, 0.4, 0.5, 16 nearly 20. So first digit is 2. So you go with the option A. Now you do simplification, taking a bit more time. Definitely you will find the answer 0.2 centimeter square cube. Try it. I will leave it for you. You try it at home. After watching this video, you try on your own. You will get a value around 0.2 centimeter cube. Here what you have done? You have written actually 10 power minus 3 whole cube. 3 3 is a 10 power minus 9. That's why if you get power 10 power minus 9, that will be equal to 1 centimeter cube. 1 centimeter cube in meter cube, 10 power minus 9 meter cube. That's why if you get 10 power minus 9 power here by shifting the decimal places, that is equivalent to 1 centimeter cube. Because 1 centimeter 10 power minus 2 cube, you can do that. Next one, children, is on bulk modulus. A solid sphere of radius 20 centimeter is subjected to a uniform pressure 10 power 6 Newton per meter square. The bulk modulus of the material 1.7 10 power 11 decrease in the volume. Bulk modulus, I'll explain the hint, you try, it's very easy. Change in pressure divided by, or pressure exerted, stress divided by delta V by V is decrease in pressure. That's why minus delta V I take this way, minus delta V, decrease in volume in fact. And this goes to numerator. So change in pressure into volume divided by bulk modulus. So how do you continue? Delta V, change in volume. I write a change in volume, delta V, that equal to pressure times what's volume? 4 by 3 pi r cube divided by B. Put the values, simplify. Pressure 10 power 6. Dense bulk modulus 1.7 10 power 11 into 4 by 3 into 4 divided by 3 pi 3.14 times what's R? Radius. How do you write radius? Radius can be written 20 centimeters. Centimeters divided by 100 becomes 0.2 meters, and that is 2 10 power minus 1. 2 10 power minus 1 whole cube. Now you simplify using proper power, conversion of power. You get a value around 0.2. You try simplification on your own. While doing simplification, you separate out the value to be multiplied for 3.14 into 2 cube, 8 divided by 1.7, and power. Numerator 6, and this is minus 1, 3 is a minus 3, and this 11 comes to numerator, becomes minus 11. Simplify power and also find the value. It will come around, I think here he says 4, but it comes around 0.2. Check the value. You just approximate the value to be around 0.6. 0.2. And ಇಲ್ಲಿ conversion 1 centimeter cube. How do you write 1 centimeter cube? Is 10 power minus 2 meter. If you cube it, it becomes 10 power minus 6 meter cube. So 10 power minus 6 power ಬಂದ್ರೆ ನೀವು ಅದನ್ನ can write 1 centimeter cube. ಅದು ಬರುತ್ತೆ, ಚೆಕ್ ಮಾಡಿ. You try it on your own. We'll move on. Next one, a steel wire of cross-sectional area. You make it area 3 10 power minus 6. Once again, area given. Can withstand a maximum strain 10 power minus 3. The Young's modulus of the steel is 2 10 power 11. The maximum mass the wire can hold. First of all, you solve for from Young's modulus formula, force by area into delta L by L. L comes to numerator by delta L. Here force is weight. What is weight? mg. Weight is mg. I read this. Okay, weight is mg because by applying a weight you are pulling it down. Area given, yes, area is given, and L by delta L. So you have to solve for m. If you solve for m, you just bring this to left side, that is y side, y into a into L divided by m. G and L come to the denominator. Put the values. He has given the value of Young's modulus, which is around 2 10 to the power 11. The value of area, 3 10 raised to power minus 6 into increase in length. What is increase in length? He says it can withstand maximum strain. He has given strain itself. That's delta L by L. He gives delta L by L. Delta L by L is given. What is delta L by L? 10 raised to the power minus. Not just delta L or L. Delta L by L ratio given. Whole divided by what is G? 10. That's it. Now if you simplify, the answer will be exactly 60 kg. You can easily guess the answer because 2 3s are. First digit must be 6. You have only in one option, that is B, 6. In other remaining 3, no 6. That's why you continue with this. If you solve, if you simplify, that must be the option. Otherwise, none of them can be an answer. That's why you mark 60 and go. If you solve, you will definitely get 60. Try it once, right? Okay. Next one. A cable that can support a load of 800 Newton is cut into 2 equal parts. The maximum load that can support is load or breaking stress. How do you calculate? Y, Young's modulus, stress divided by strain. Stress by strain, you can use this. Or what is stress? First of all, stress is force by area. So you solve for F. Stress into area. Stress into area. Area of cross section of the wire. Force, that is the breaking strength. He says a cable supports 800 Newton is cut into 2 parts. The maximum load that maximum load that can be supported by either part. Breaking force is proportional to area of cross section. Since area of cross section of the 2 wires, initially wire was of this length. Now it is cut into 2 parts, right? Both having same area. That's why, since area is same for both the wires, breaking strength also a constant. It doesn't depend on the length. If you make it a half, the force is halved, something like that is not there here. It is independent of length. It depends only on the area. If you change area, then the force per unit area, stress effect changes. But if you change length, nothing will happen. If you take 1 meter wire or 100 meter wire, to break it, force required is a constant. Doesn't depend on the length. If you take more length, more force required. Less length, less force. Not like that. Here, breaking stress or strain, breaking force or stress depends only on the material and area. Material area. That's why you can say area. So the force remains 800 only. Before you cut, breaking strength is 800. After it is cut into 2 halves, breaking stress remains the same. That's what you have to remember. Yes, one more. A area of cross section of a wire 1.1 meter. Length, initial length is given 1.1 meter. Right? Is 1 mm square. Area is 1 mm square. Is loaded with 1 kg. If the Young's modulus of copper is 1.1 10 power 11 Newton per meter square, the increase in length will be. What is the increase in length you have to find? Same formula, that is increase in length, that is Young's modulus Y, F divided by A into delta L by L. So L goes to numerator, L by delta L. You want increase in length, that is delta L, change in length, delta L, F by A into L by Y. What's L here? Length given, what is that? 1.1 meter. F is mg because weight is applied, some weight, into L divided by AY. So he has given M as 1 kg into G10 and length of the wire 1.1 meter divided by area of cross section 1 mm square, 1 millimeter, 10 power minus 3 meter whole squared. So 10 power minus 6, 10 power minus 6 into y. What is y? Y is Young's modulus 1.1, 10 raised to power 11. So 1.1 cancels. And this comes to numerator, becomes 11 minus 6, 5 plus 5. Plus 5 comes to numerator, minus 5. Minus 5 plus 1 here, 10 plus 1. Minus 4, 10 power minus 4 meter. If you write 10 power minus 1 into 10 power minus 3 meter. What is 10 power minus 3 meter? Millimeter. What is 10 power minus 1? 0.1. 0.1 millimeter. That is the answer. Option A should be is missing. Make it 0.1. Okay, right. That's about the problem. Yes, children, in this problem, A and B are two wires. Radius of A is twice that of B. What it says? Radius of A, RA, is 2 times RB, second one. They are stretched by same load, means force is same. Then the stress on B is, stress is force by area. F is a constant in our discussion. Since F is a constant, stress inversely proportional to area. Area. What do you write for A? Pi r squared. So if I write stress by symbol is proportional to 1 by r squared, which implies stress of wire A. He wants you to find stress of B, in fact. Stress B divided by stress A. Stress B by stress A. Right. Stress A. Okay, right. That equal to stress inverse proportional to radius. That's why R of B denominator, R of A numerator, whole raised to the power 2. He says R A 2 times that of B whole square. So it becomes 4. It becomes 4 times. That's the answer. Yes. A steel and copper of same length are stretched by the same weight, one after the other. Young's modulus of steel and copper are 2 10 power 11 and 1.10 power 11, the ratio of increase in length. Here, copper and steel have same length, stretched by same weight. Weight means force. F same, L same, right? And same wire, area also same, otherwise you cannot solve this. Area he is not mentioning, which means same. So what is increase in length? Increase in length proportional to Young's modulus, inversely or directly. They are proportional to inversely. How? Because Young's modulus, that is F divided by A into L by delta L. Y inversely proportional to L. So Young's modulus of say steel, I write steel numerator, increase in length corresponding to steel to that of copper is equal to inverse relation to Young's modulus. So Y of S denominator, Y of C numerator, Y of C copper 1.2 10 power 11 divided by 2 10 power 11. 11 cancels, this is 2. 0.6, or you can write 4 3s are 4 4s, I can write, or you can write 12 divided by 20. This way also you can try. Let's remove this idea. Okay. 12 by 20, 4 common factor, 4 5s are 4 3s are. So it is 3:5. Option B. Right? You will see now. 23rd. A rod of length L and area of cross section A are heated from 0 to 100 degree. The rod is so placed that is not allowed to increase in length. Andre rod is not allowed to increase in length because rod when heated increases length. Allow ಮಾಡಬಾರ್ದು increase ಆಗಲಿ, means ಆ ಕಡೆ ಈ ಕಡೆ ರಿಜಿಡ್ ಸಪೋರ್ಟ್ನ ಕೊಟ್ಟಿದ್ದೀರ ನೀವು. Allowed to increase, then force developed is proportional to. What do you think about force here? Force developed temperature force. Thermal force formula we all know. We have been solving this some 4-5 cases, right? F that equal to y alpha delta theta area. Just get it by heart. Young's modulus, coefficient of linear expansion, change in temperature, area of cross section. So the relation between area and force, area proportional to force, because rod of length L, same length, area of cross section is heated from 0 to 100 degree. The rod is so placed that it's not allowed to increase in length. Length increase ಆಗಲಿ ಬಿಟ್ಟಿಲ್ಲ ನೀವು. ಲೆಂತ್ ಇನ್ಕ್ರೀಸ್ ಆಗಲ್ಲ ಅಂದರೆ ಏರಿಯಾ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಇಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಏರಿಯಾ. So what do you say? Then the force is proportional to area. You are not allowing it to increase lengthwise. Y is same, alpha is same, delta theta is same, 0 to 100 degrees. So force is proportional to area. That's the idea. It's very simple. Next we'll see, children.